Hey guys, we are going to take some time to review all the topics that we've done so far here in this first quarter. Okay, so we'll split this into two videos. So we'll do the first half in one video, second half in another. So starting with f of x plus g of x and find the domain. So that's x plus 5 plus 4 over x minus 3. In order to add these, I have to have a common denominator. So I need to multiply this one by x minus 3 over x minus 3. Okay, so I need to distribute here. So I get x squared plus 5x minus 3x. So that's plus 2x minus 15. And now that they have a common denominator, I can put this plus 4 into the same fraction over x minus 3. So now I will combine like terms, so I get x squared plus 2x minus 11 all over x minus 3. There's not going to be anything that multiplies to negative 11 and adds to 2, so I won't be able to factor this, so this will be my simplified form. And for the domain, I have to make sure my domain satisfies f of x, g of x, and this composition. There's no variable under a radical or in a denominator in f of x, so the domain here is all real numbers. Here, the denominator cannot be 0, so x cannot be 3, and here's the same, x can't be 3, so the only restriction is that x cannot be 3. F of x divided by g of x. So that's x plus 5, and I'm going to turn that into a fraction over 1 over 4 over x minus 3. Okay, now I can divide, or I can multiply these. This outer loop here will give me the numerator, and I've already multiplied these over here. So I'll just take this x squared plus 2x minus 15 over, and then this inner loop here gives me the denominator 4 times 1. Okay, so there is my quotient. Now I have to write a domain that satisfies all three, f of x, g of x, and the composition. All reals, can't be 3, and this is all reals because there's no variable in the denominator or under a radical. So once again, the only restriction is that x cannot be 3. Okay, find f of g of x. So that means that we are taking g of x and plugging it into f of x. So this can also be written as f of g of x. So g of x goes in for x's in f of x. So this is going to go in for this x and this x. So that's 11 times x squared minus 7 over x squared minus 7 minus 3. So I'll distribute in the numerator 11x squared minus 77. And in the denominator, I can combine like terms, x squared minus 10. Graph these equations. So when I'm in standard form, I like to make a t-chart where I put 0 in for x and for y. When I put in 0 for x, I get negative 12y equals 48, and 48 divided by negative 12 is negative 4. So I have 0, negative 4. And then put in a 0 for y, so I have 8x equals 48, and 48 divided by 8 is 6, so I have 6, 0. So the slope here is up 4, right 6. Simplified is up 2, right 3, so I'm going to go up 2, right 3, and then down 2 and left 3. And there's my line. Okay, we need to fill up the graph with as many points as possible to keep the slope and put arrows on each end. Here I'm in slope-intercept form, so the y-intercept is 3. The slope is negative 1/2, that's down 1 and right 2, as many times as I can fit on the graph, and up 1 and left 2 as many times as I can fit on the graph. write an equation in slope-intercept form for each line description. So here's the slope and here's a point, so I'll use that as m, and here is x1, y1, and we'll start in point slope form. Y minus y1 equals m times x minus x1. So y minus y1 is 6 equals m, which is negative 3, times x minus x1, which is 2. Okay, so I'll distribute. I get y minus 6 equals negative 3x plus 6. And add this 6. Y equals negative 3x plus 12. So there it is in slope-intercept form. This next one, I need to find the slope and choose an x1, y1. Okay, so the slope is y minus y, 11 minus negative 7, over x minus x, 1 minus 4. So that's 18 over negative 3, and that simplifies to negative 6. So there is m. And then I'm going to use the two positive numbers as my x1, y1. It does not matter which point I choose. I'm choosing A. Y minus y1 equals m times x minus x1. So that's y minus 11 equals negative 6x plus 6. And then add that 11, y equals negative 6x plus 17. Okay, this time we're going to write in standard form, and it's going to be a line parallel. So we need to know the slope. The slope of this line is the opposite of A over B, so that's negative 7 over positive 4. The slope of a parallel line is the same, negative 7 over 4. So there's my slope, and here is x1, y1. Y minus y1 equals m times x minus x1. So we get y plus 3 equals negative 7/4 x, and then positive, and 8 over 4 is 2, so it's 7 times 2, 14. Now I will put this x on the left, I'll put the constant on the right, so I get 7/4 x plus y equals 11. Okay, now we need to make sure A is positive, which it is, so we don't have to worry about that. We also need to make sure there's no fractions, but I have a fraction here, so I will multiply this entire thing by 4, and I'll get 7x plus 4y equals 44. If this was negative, if A was negative, I would have just multiplied by a negative 4. Okay, standard form again, this time perpendicular. So the slope of this line is the opposite of A, that's negative 5, over B, which is negative 2. So the slope here is 5/2. The slope of a perpendicular line is the opposite reciprocal of 5/2, so it's negative 2 over 5. And here's x1, y1. Y minus y1 equals m times x minus x1. So I get y minus 6 equals negative 2/5 x, and then positive 5 over 5 is 1, so I have 2 times 1, which is 2. I'll move the constant right, the variable left. 2/5 x plus y equals 8. And then I will multiply everything by 5, so I don't have any fractions. 2x plus 5y equals 40. Okay, graph this piecewise function. The first equation is y equals 7, but I can only graph it for x's that are less than negative 2. So negative 2 is right here. I can only graph on the less than side, the left of that. So y equals 7, so that's up here, but only left of x equals 2. So it looks like this, and then I need to decide if I'm going to leave this open or if I'm going to fill it in. It is not less than or equal to, just less than, so I will leave it open. The next line graphs between -2 and 4. And it's y equals -2x plus 2. So I have a y-intercept of 2 and a slope of -2. Down 2, right 1. And I'll keep going down 2, right 1 until I get to the edge of my domain. I'll put a circle there. Up 2 and left 1. And I'll put a circle there. And I'll connect those. Okay. Then I have to decide if these are left open or if I fill them in. It's greater than -2, so I'll leave that open. Less than or equal to 4, I will fill that one in because it could be equal to. And then 1/2 x minus 4, but only for x is greater than 6. So here's x equals 6. I can only graph to the right of that. So my y-intercept is -4. So I'm going to come to the y-axis and go down 4. But I can't graph until I get into the domain. So I'll go up 1 over 2, up 1 over 2, up 1 over 2, and here I am at the edge of the domain, up 1 over 2. It looks like that. And it is not equal to, so I will leave this open. Okay, so now we'll graph an inequality. So I will make an XY chart. X is 0, Y is 0. When I put in a 0 for X, 36 divided by -12 is -3. So I have 0, -3. And then put a 0 in for Y. 36 divided by 9 is 4. So I have 4, 0. Up 3, right 4. That doesn't simplify, so I'll continue up 3, right 4. Down 3, and left 4. Okay, so here is the line. And it is underlined, so I want a solid line here. If it was not underlined, this would be dotted. Okay, now we'll test the origin. 9 times 0 minus 12 times 0, so we're testing 0, 0, is less than or equal to 36. So that's 0 is less than or equal to 36. And that is true, which means I shade toward 0, 0. Okay, when 0, 0 makes a true statement, you shade toward it. So the shading is up here toward the origin. Okay, so now we have an absolute value. Okay, so this absolute value graph, an absolute value parent function is a v up here, and it's shifted down 3. So we're just going to take an absolute values vertex and shift it down 3. And it is greater than but not equal to, so we'll make it dotted. We need to make sure the slope on the right side is 1, and the slope on the left side is -1. So we'll make sure we hit all the points correctly, make this precise. Then we test the origin. 0 is greater than the absolute value of 0 minus 3. So that 0 is greater than -3, and that is true. The origin makes a true statement, and we shade toward the origin. So we shade inside. Okay, here we have a compound inequality. Okay, so I've got an inequality right here. So I'm going to make an XY chart, 0 and 0. Put in 0 for X. And 12 divided by -4 is -3. So I have 0, -3. Put in a 0 for Y. 12 divided by 6 is 2. So I have 2, 0. Up 3 and right 2. And I'll do that as many times as I can. And down 3 and left 2. Okay, and this is underlined, so it will be a solid line. Okay, and when I test the origin, I get 12 is less than or equal to 0, and that is not true, so this one will shade this way away from the origin. Okay, then I have an inequality here, so I put in my zeros for X and Y. 36 divided by 6 is 6, so I have 0, 6. I put the 0 in the wrong spot there. I put that 6 in the wrong spot. When I put a 0 there, I get negative 9, so I'll have negative 9. And then I'll put the 0 in for y, and 36 divided by 6 is 6. So 36 divided by negative 4 is negative 9. 36 divided by 6 is 6. So I get 0, negative 9, and 6, 0. So that's up 9, right 6, and that simplifies to up 3, right 2. And this is not underlined, so this will be dotted. And when I plug in the origin, 6 times 0 minus 4 times 0 is less than 36. 0 is less than 36 is true. This shades toward the origin, and what got shaded both times was between the two lines. Okay, solve giving exact answers. I'm going to use matrices to solve these. So we'll press second and matrix, that's this inverse button. And when we are in matrix, so second and matrix, we are going to go to edit matrix 1. And because this is a 2 by 2 system, we'll do 2 by 2. And we have 15, negative 4, negative 18, 5. Okay, then we go back to matrix, so second and the matrix button again, and we edit matrix 2 to a 2 by 1, and we plug in negative 29 and 38, and then we quit, second quit. So then we do second matrix and choose option 1, and then the inverse button. So it looks like this. Inverse of matrix A times second matrix and option 2. So we have the inverse of matrix A times matrix B, and then math, enter, enter, and we get 7/3, 16. X is 7/3, Y is 16. Okay, then we do matrix A again, this time as a 3 by 3. So second matrix, edit matrix A to a 3 by 3. 3, negative 7, 7, 36, 24, negative 35, 90, negative 42, and negative 14. Then we edit matrix B, so second matrix over to edit option 2 to a 3 by 1, and we have 6, 9, 32. Then we quit, second quit, and then second matrix 1 inverse, so that's that X negative 1 button right there, and then second matrix 2. So we have matrix A inverse times matrix B, and then math, enter, enter, 17/18, 5/6, 9/7. Okay, then another 3 by 3. Okay, so I've zoomed out a little so you can see this a little bit better without me moving the calculator around. So I've got second matrix 1. We're going to edit matrix 1. We'll keep it as a 3 by 3, negative 22, negative 12, 44, 8/5, 3/14, negative 22/5, negative 104, 5, negative 187. And then second matrix, edit number 2. We'll keep it as a 3 by 1, 383 over 4, negative 29 over 10, negative 159. And I used the minus button there, so I need to go back there and do the negative button instead of the minus. Okay, now quit, second matrix 1 inverse, second matrix 2. Math, enter, enter, and we have 3/8, negative 7, 5/11. And then here we have a 3 by 3 again, and we have to put in some zeros. So second matrix, edit matrix 1 to a 3 by 3. We have 4, negative 7, and then z is 0. X is 0, 3, 8, and then 7, y is 0, negative 11. And then second matrix, edit number 2 to a 3 by 1, negative 15, negative 165, 348. Second quit, second matrix 1 inverse, second matrix 2. 12, 9, negative 24. Okay, and our last item here on this video, I need to input all 4 of these matrices. So we'll edit matrix 1. So matrix, edit, number 1. This is 1, 2, 3, 4, 5, 6, 7 by 3. Okay, so there's matrix 1. Then for B, we'll go to edit matrix 2 to a 3 by 2. I'm sorry, that's a 2 by 3. Okay, then we'll edit matrix 3 to a 2 by 3. And we'll edit matrix 4 to a 3 by 1. And we'll quit, second quit. And then we have 5, so parentheses, 5 times matrix B plus matrix 3 times matrix 4. Okay, so negative 6, 235. A times D, so second matrix 1, second matrix 4. Okay, so we have negative 28.1, 10.8, 52, 27.3, 5.7, 7.7. Then we'll use that down arrow, and we have negative 21.7. Sorry about that bell. Clearly I've gone a little over my time. So here's our answer for 19. For number 20, we have C minus D. So that's matrix 3 minus matrix 4. And that's a dimension mismatch. So C minus D is not possible. And last we have 21B times C. So that's matrix 2 times matrix 3. And we have another dimension mismatch, so this one is also not possible. Remember, in order to add or subtract matrices, like for number 20, they have to have exactly the same dimensions. C and D do not have the same dimensions. To multiply, the dimensions have to have a match in the middle. So we have a 2 by 3, and here C is also 2 by 3. We could add or subtract them, but these middle dimensions do not match, so we cannot multiply them.